Welcome to the second part of video 5, where we will complete the summary presentation for the video series on wildlife management principles. In this final video, I would like to revisit the main issues and lessons from video 4, where we use the computer model to explore wildlife harvesting strategies, and then provide some concluding perspectives. With respect to wildlife harvesting strategies, there were two main questions we explored in video 4. The first was, does it matter if environmental and habitat conditions are constant or variable? Based on our computer simulation modeling, the answer was yes. Fewer animals can be sustainably harvested if environmental and/or habitat conditions are variable. These graphs show how a non-harvested moose population might grow under a constant environment versus a variable environment. The key pattern shown here is that even when populations are not harvested, population size in a variable environment may sometimes drop randomly below desired levels. This is because a variable environment can randomly reduce calf survival and also increase mortality rates. In northern moose populations, this is often expressed as severe winter conditions that cause more animals to lose condition, fail to reproduce, and/or starve. The second question we explored through the model was, does it matter whether males or females are harvested? Once again, based on our computer simulation modeling, the answer was yes. Fewer animals can be sustainably harvested if females are predominantly harvested. These next graphs will show population response to bull harvest and cow harvest at 5 different levels of harvesting, under the assumption of a variable environment. The key distinction between the two graphs is that a bull harvest appears to be sustainable to the extent that it does not cause an observed reduction in population sizes. A visual comparison of the colored lines suggests that the population is resilient to the bull harvesting rates, which ranged from 0 to 7%. In contrast, the graph of population responses to cow harvesting rates, shown on the right, clearly demonstrates that as the proportion of cows harvested increases from 1% to 7% of the total number of adults, the total population size decreases accordingly. At the end of the simulation run, a 7% rate of cow harvest has reduced the population to about 40% of the initial population size, at year 50. These results show that comparatively higher rates of harvesting cows are not sustainable in variable environments. Thus, from those basic sets of scenarios, we can conclude that harvesting females in a variable environment is often not sustainable. And from a broader perspective, we suggest that making wise wildlife management decisions requires collecting good information and conducting systematic evaluations of field data. Computer models can play a useful role in evaluating and interpreting field data. In the real world of wildlife management, where governments and management boards have limited resources, it is very difficult to collect the full suite of data at frequent and regular intervals for each and every population. And often, we do not have complete and up-to-date information on population characteristics, such as herd size and composition, habitat preference and distribution, reproductive parameters such as pregnancy and productivity rates and birthing intervals, natural mortality from predators and winter kill, and harvest mortality. These population characteristics often represent data gaps or key uncertainties for wildlife managers, who still have to make management decisions about harvesting populations with less than complete information. Therefore, given that we will have data gaps and incomplete population information, we need to think about managing and reducing risk of over-harvesting wildlife populations. The first step towards reducing risk is to collect population data. Subsequent steps involve deciding what the priorities are for population information and how frequently it is collected. For example, let us consider a graph that has the frequency of population monitoring along the horizontal x-axis. So on the left-hand side of the x-axis are situations with population and harvest monitoring surveys that have low resolution and low frequency, i.e. surveys are conducted once every 10 years. As you move to the right, you are increasing the resolution and frequency of population and harvest surveys towards a yearly interval. On the vertical y-axis, the scale indicates that we go from low to high with respect to our knowledge of the population, our confidence in management recommendations, and most importantly, a relatively low or high harvest allocation. This red line shows that there is a relationship between the resolution and frequency of monitoring and our confidence in management, which is reflected in our level of knowledge and the relative size of the harvest allocation. So if we are conducting low resolution monitoring at a low frequency, such as once every 10 years, then we will have a low harvest allocation because our knowledge and confidence in management is relatively low. By increasing the frequency and resolution of the population and harvest monitoring, we can start to increase our knowledge, confidence, and harvest allocation. We can improve our knowledge, confidence, and allowable harvest allocation further if we increase our monitoring resolution and frequency further, for example, every 3 years. The main point of this graph is that the level of knowledge, confidence in management strategies, and level of harvesting will vary with the quality and frequency of the population and harvest monitoring programs. Regular surveys and monitoring allow us to increase harvest rates, but they cost money. So there can be a trade-off in the cost of frequently acquiring good monitoring information with the level of harvesting. A precautionary approach is to harvest populations conservatively. In other words, we would recommend relatively low harvest rates when there is not a lot of available information for a wildlife population. A final perspective is that good information allows us to use the power of computer models to develop foresight about how harvesting may affect wildlife populations. Modeling and computer models are useful tools for assisting wildlife managers in evaluating and interpreting field data and developing and exploring management options for decision makers. Thank you very much for your interest, and I hope that you have found these videos helpful.